So what we're going to do is we're going to learn two different ways to solve these by hand without drawing a graph. The first method you've probably seen before is called substitution. In substitution, we take one of the two equations, whichever one's easiest, you get to pick, to get a variable by itself. Well, if we look at this first example, A, we've got 4x plus y equals 5 and 2x minus 3y equals 13. The easiest equation to get a variable by itself would be if I look at the first equation. I'm going to label that as my number one equation because I'm going to use it first. So I'll use the 4x plus y equals 5 equation first. What variable is easiest to get by itself? Well, the easiest to get by itself would be this y by getting rid of the 4x by subtracting 4x from both sides. What does this get me? This gets me that the y is going to equal negative 4x, and that's a positive 5, so plus 5. So what this will now let me do is replace any y's I see with this negative 4x plus 5. So where am I going to use this? I'm going to take this and plug it in for y into the equation I haven't used. Well, what's the equation I haven't used? I haven't numbered it even yet. So that'll be my second equation. My 2x minus 3y equals 13, the one equation I haven't used. And what am I going to do? I'm going to be plugging something in for my y. What am I going to plug in? This negative 4x plus 5. So I'm going to plug that in. Remember, when you plug in anything or substitute anything into an equation, remember when you plug that in, the negative 4x plus 5, I have to put parentheses around it. Everything else, the 13 on the other side, the negative 3 out in front, the 2x, all stay the same. Now what? Now I have to deal with my parentheses. I have a negative 3 out in front, and those parentheses are telling me I have to distribute my negative 3 to everything on the inside. So I'll end up with 2x out in front. That won't get touched. Negative 3 times negative 4x will give me positive 12x. Then the negative 3 times the 5 will give me negative 15 equals 13. Now we can combine like terms. The 2x and the 12x are like terms that can just be added and subtracted normally because they are on the same side. That will get me a 14x. We still have the minus 15 equals 13. So we can keep on solving this like we would a normal equation by adding the 15 to both sides. That will get me, let's see, a 14x equals 28. Then I can divide both sides by 14. And that will get me an x equals 2. However, I am not done. This is only half of my answer. I still have to figure out again, if my lines are intersecting at a point, I've only got half of my point. I've got my x, I still need my y. So I'm going to take my answer for x and plug it back into the previous step, or step 1, wherever there's an x. So I'm going to replace that x with a 2. So I'll get negative 4 times 2, which is negative 8, plus 5 is, let's see, negative 3. So that's my y value for my point. So if I write out my final answer, let's see what I get. I get the point, well, we said our x was 2, and our y was negative 3. So I get the point 2, comma, negative 3. That's our final answer. And that means that these two lines will intersect at that point. In problem B, I don't